So what have I been talking about? Well, the CoaX platform. We are basing this on a manned aircraft. What we'll be doing with the US is using technology that exists. This piece of kit is amazing. Its manoeuvrability is second to none. Its low noise footprint is exceptional. Its robustness is astonishing. You'll see as this video plays the type of capabilities that this aircraft has. The efficiencies of a CoaX rotor head, of course, 10 to 15% better use of the thrust available. No tail rotor to whack people in the face or do much more severe damage. No tail rotor to be engaged in rotor strikes. The flexibility of this airframe is something that we're going to take to the world. We hope to put a diesel power plant on that. We're negotiating at the moment with a company called Ostro in Austria. They have produced a diesel power plant, aviation certified, EASA, FAA and Australian certification, producing something like 150 horsepower. At its optimal rating of 125 horsepower, the fuel flow is down around the 25 to 30 litres per hour. Putting a gas turbine engine aside, taking a diesel power plant with ubiquitous availability of fuel, current maintenance time of operation 1,200 hours, hopefully extending out to 2,000 hours. If we can do the same with the transmission and the rotor head, we will have something that will be a tractor in every farmer's garage. The auto-flight system I'll talk a little bit more about as well, but it is highly accurate. Some 2 orders of magnitude better fidelity than the A330 I fly today. Extremely high accurate. We hope to design this with an independent carriage and payload system. The top half should be ubiquitous. The bottom half will carry our dispersal systems for aerial ag, will carry our search and rescue systems, will carry our ISR, may even carry our optional pilot, should we elect to go down that pathway. But the one thing that we give the UAS industry, particularly in civilian applications, is the capacity to provide lift. Virtually all UASs right now provide ISR. We will be out there doing the job. So what are the opportunities for us? Firstly, obviously, aerial agriculture. Spraying, seed laying, all of the things that Chris spoke about earlier with surveillance of pestilence. One of the big concerns, however, for aerial ag is that the accident rate is very high. The other opportunity we give aerial ag is that we are not day VMC limited. We can operate when the time is most appropriate for whatever that application would be. Mining exploration, similarly. One of the concepts might be that you have an optionally piloted vehicle, takes the minerals expert out to the field, gathers samples, puts those in the helicopter, says, go home, take it back and do some assays for me. Come back when you're ready and I'll give you some more. The flexibility that we have with this type of platform is quite unlimited. Civil emergency. Obviously with the Brisbane floods here recently, a major catastrophe. One that I'd like to talk about in particular though was the Christmas Islands asylum seeker boating disaster. One of the big issues that the search and rescue teams had there was identifying and locating the people that were in the water. The sea state was so high, it was not possible from sailing around on a rib or other sea level devices to actually see where these people were. With an airborne platform carrying some sort of IR kit, you would be able to very easily locate those people. But that's not the end of the story. Had we had something similar in capacity to what CoaX provides on a vessel the size perhaps of a patrol boat, it gives the opportunity then for the on-scene commander to make not just decisions about ISR and communication, but about lift. Would he like to take out a survival raft? Would he like to take out a whole bunch of survival vests? Would he like to change the mission profile depending on what he sees on the day? If he's got lift capability, he can do that. It's not just the ISR we're after. The advantage that we have, this whole system is Australian designed and using an Australian designed and built autopilot by Cyber Technologies. They have recently been proven by DSTO to be unparalleled in their system accuracy. I won't tell you the size of the box that this aircraft can fly through with this autopilot, but it is extremely small. The system is already ADS-B compliant, frequency agile data link for security of communication and video compression. All of the stuff that you would expect on a currently existing fixed-wing ISR aircraft. And the reason that we're using that is because it already flies. Programmable accuracy means that we can do all the types of work that we want to do without the human factor causing errors. We can sit down and be extremely accurate in how we're operating this. Obstacle avoidance, if we know on a farmer's property, for example, where a power line is, we will never hit it. We will be able to stop just prior to the boundary. We won't have overflow of pesticides going into adjacent properties. And of course, we must have, and we do have, mission fail-safe logic built in. If we lose communication, the capacity for the aircraft to know that and either land or recover is already built into the auto-flight system. The advantages, as I've alluded to, 24/7. We can operate in fog. We can go out and do grapevine anti-frost mitigation. We can lay down fertiliser when the moisture content is just right. Not VMC limited. Lower skill set. As I said before, we can do this in a task-orientated fashion. With the correct certification, with the correct training, we train for the particular task. And yes, our goal is not to sell aeroplanes, it's to sell capability. And finally, we want to prove to the regulator this is the safest way to go. If we can prove that we eliminate deaths, particularly in aerial agriculture, we have a very strong case to say, why do you bother doing this with a manned aircraft? But we still have hurdles to overcome. We have a major test flight schedule. So where do we go with the UAS? Is it a manned certification? What are the rules for an unmanned aircraft of this size? We have to work very closely with Phil to work through the available civilian manned aircraft certification process, the STANAGs that are already out there for military systems, and try to build a first place process for us to take CoaX helicopters to the market. The regulatory restrictions I've already highlighted are something that I spend a lot of time considering, speaking to the industry, speaking to the regulators, and try to advance the cause for all of us to operate unrestricted. Public perception, as alluded to by Phil this morning in his presentation from John McCormick, is something that we all have to work on to try to overcome. Sense and avoid, I think, is something that we're still in the infancy of. We've heard from from ARCA this morning about their pixelation technology and being able to identify and locate, then avoid flying objects. ARCA is also, and CSIRO, involved in a laser-based obstacle collision avoidance system. Many of these will need to be integrated before we can have full confidence about the capability of the UAS to firstly abide by rules of the air, secondly abide by the control and constraints issued by the regulator, and thirdly carry out collision avoidance last-ditch manoeuvring. Industry resistance. Unusually high problem that I see. I recently read a document put out by some other pilots in my own industry that said UASs should never operate in controlled airspace. End of story. Not even going to think about it. So if we have these brick walls that are up against us, it's a challenge for us all to educate, to formally go out and advocate what UASs are doing. But should we do that, we'll be in a very good place. So where do I see the future? The US would like to see 40% of their manned military hardware unmanned. There will always be flow-ons from the military systems to the civilian ones, and we will capitalise on that. My question to you, is the F-35 going to be the last manned fighter? But anything that's dull, dirty and dangerous, these are the areas that we, and particularly with our CoaX platform, are looking to target. But we've got to do it safely, we've got to do it soundly, and we've got to do it cost effectively. In summary, the great thing about being here is that we are Australians. Australians are not followers, we are leaders. We identify a problem, we tackle it, we resolve it, we go out and we lead and we achieve. Right now, with John McCormick sitting at the top of the directorate that controls the regulator, the implementation by Jim Coyne and Phil Presgrove, and the facilitation by Peggy McTavish mean that we have an opportunity now to actually take an industry piece of equipment out to the world. It's great being in an Australian company. That's why I believe that CoaX helicopters will be the first civilian VTOL UAS. Thank you.